An investment is initially worth $10,000. Write a formula for the value of this investment for each situation described. A, the value increases by 5% every year. B, the value increases by 5% every 3 years. And C, the value increases by 5% every 6 months. We'll be writing the formula as an exponential function in the form f of t equals a times b raised to the power of t, where a is equal to the initial value or starting amount, b, the base, is the growth factor, which is equal to 1 plus r, where r is the growth rate expressed as a decimal. So in each situation, the initial investment is $10,000, which means a is equal to $10,000. In each situation, the growth is 5%, which means r is equal to 5% as a decimal. This is equal to 0.05. And b, the growth factor, or the base, is equal to 1 plus 0.05, which equals 1.05. But each situation is going to have a different function or formula, because notice how the time period for which the 5% growth is realized is different. In A, it's every year. In B, it's every 3 years. And in C, it's every 6 months. For each formula, let's let t equal time in years and v of t equal the investment value after t years. Let's first focus on A when the value increases by 5% every year, which means after 1 year, or when t is equal to 1, the value will increase by 5%, which means the value is equal to 10,000 times 1.05. By multiplying by 1.05, this will give us the value after one 5% growth. So we can also express this as 10,000 times 1.05 raised to the first. After 2 years, the value increases by 5% twice, which means you'd have to multiply 10,000 by 1.05 twice, or 1.05 raised to the second power, or 1.05 squared. And after 3 years, the value increases by 5% 3 times, and therefore the value of the investment is 10,000 times 1.05 raised to the third. Now let's focus on the value of t and the value of the exponent. Notice for this situation, the value of t and the value of the exponent is exactly the same, which means for our formula or the function giving us the value of the investment, for part A, we have v of t equals 10,000 times 1.05 raised to the power of t. And now let's focus on B when the value increases by 5% every 3 years. In this situation, it takes 3 years for the value to increase by 5% one time, which means when t is 3, the value is equal to 10,000 times 1.05 raised to the first. Again, it increases by 5% one time after 3 years, which means when t is equal to 6 or 6 years, the value increases by 5% twice, which means the value is equal to 10,000 times 1.05 raised to the power of 2, or 1.05 squared. And then after 9 years, the value would increase by 5% 3 times, and therefore the value is 10,000 times 1.05 raised to the third. To help us write the formula, let's compare the t values to the exponent values. When t is equal to 3, the exponent is 1. When t is equal to 6, the exponent is 2. And when t is equal to 9, the exponent is 3. Notice the value of the exponent is 1/3 times the value of t, or we can say the value of the exponent is t divided by 3. So for part B, we'd have v of t equals 10,000 times 1.05 raised to the power of t divided by 3 over 1 or 2 1/3 t. And now let's focus on part C when the value increases by 5% every 6 months. Because t is time in years and 6 months is equal to 1/2 a year, or 0.5 years, for our table, let's begin by letting t equal 0.5, which is half a year or 6 months. And over this time period, the value increases by 5% one time, which means the value is 10,000 times 1.05 raised to the power of 1. After 1 year, or when t equals 1, this would be two 6-month periods, and therefore the value increases by 5% twice, and therefore the value would be 10,000 times 1.05 squared raised to the second power. After another 6 months or half a year, or when t is equal to 1.5, the value increases by 5% 3 times, and therefore the value is 10,000 times 1.05 raised to the third, or 1.05 cubed. Again, let's compare the t values to the exponent values. When t equals 0.5 or 1 half, the exponent is 1. When t is 1, the exponent is 2. When t is 1.5, the exponent is 3. Notice how the value of the exponent is twice the value of t, and therefore for part C, we'd have v of t, the value of the investment, is equal to 10,000 times 1.05 raised to the power of 2t. Whatever the value of t is, to get the exponent, we need to multiply by 2. Before we go, let's compare some of the values in these three situations. This first table is when the growth is every year. This is the table when the growth is every 3 years. And this is a table when the growth is every 6 months. So in the first table, notice how after 1 year, the value is $10,500. In the second table, notice how it takes 3 years to reach the same value of 10,500, again because the value increases by 5% every 3 years. And for this last table, the value is 10,500 after 0.5 years or half a year, because the growth is 5% every 6 months. Going back to the first table, after 2 years, the value increases by 5% twice, and therefore the value is $11,025. When the growth is 5% every 3 years, it takes 6 years to reach the same value, and when the growth is every 6 months, it only takes 1 year to reach the same value of $11,025. So these tables do verify our formulas are correct. I hope you found this helpful.